guys. So in this video we are going to see this algorithm, SLIC segmentation algorithm in Matlab. So this is going to be a very informative and a fun video. So in this video I'm going to show a lot more features of Matlab that I just discovered. So we'll also see that. Also please watch the whole video, because at the end of the video I'm going to show you something very nice. So this is the result of a mistake that I have done, but the image looks very nice to me. So I'm going to show you how did this image come. So from this image I generated this fiery kind of image. So we'll see at the end how can we generate this kind of an image. So we'll see how I've written the code for SLIC segmentation. Before that, I want to just run the code and show you some very beautiful features of Matlab that I just discovered. So let's see that. So here you can see when I run the code, it is telling me now which file to open or which image that I want to select. So you know that in my previous video I have to put this path, the image path over here in imread. So now with these two commands, now I can select a particular image from the file browsing, like that is shown over here. So this is a very nice thing that I just explored. So like this you can just select some image. Say I want to select this image, just double click on that and your algorithm will start running. So this is a very nice feature, that instead of typing the name over here, you can just directly put this particular thing over here. So that is one thing. The next beautiful thing is this thing. So since this algorithm takes a little time, so I thought why not use some GUI features of Matlab and show the the user, or show us how much has the code progressed, so that we can use with this particular thing. So this thing uh, is because of this thing. I'm going to show in the code how I'm doing it. So there's this wait bar, there's this thing called wait bar. With that wait bar we can do this kind of a thing. So this is telling me how much has the code progressed, and you can write whatever you want. So here I've written segmenting, so it is telling segmenting. If I change this particular thing, then I will get a whatever I've written over here will come over here. So this is a different GUI kind of a thing which will, so this is some features of Matlab that you can always use. So that is what I wanted to show you in this video. So along with the code, the SLIC code, I'm also going to show you how to implement these things and that fiery kind of a image that we saw. So first let this code run, so that I'll show you how the output comes. So I hope that you have seen this video of mine, that is SLC segmentation, how the algorithm work. So if in case you have not seen this video, I suggest you to just click over here, so you will be redirected to this video of mine. So there I've explained how does this algorithm actually work, and we are going to implement the same algorithm here. And this image is also that I have taken is from this this Matlab code itself. So these are the nice images that we can obtain from this algorithm. So we'll see that. Right, so I guess the algorithm is almost over. Yeah, yeah. So this is the output that you can see. So this kind of an output you can get, and I'm also showing the edges, so you can understand how many so the prominent ones can be seen over here. So we'll see all these things now. So let's start debugging the code. So let me put the breakpoint so that I can debug the code. So we know we know how to debug. We can put breakpoints over here and just press run, so it will come till that breakpoint, this arrow. So the code has executed till here. Now there is this command, you get file. So with this command you can get that browsing kind of a thing. So when I step this, so you get this browsing kind of a thing. So this is one important thing that I wanted to share. So here you can select whatever image you want. So here I'm selecting this one. Then next is here you get the file, that is the name of the image, and the path, that is this path where the image is. You get both of the things from here, file and path. So now you have to merge both of them. So full file will merge both of them for you. So here you can see in F you have the whole path of the image, and that you can just IM read. So in A you can see the image is read over here. Next, if you see the algorithm, so first step is to convert the input to the C lab space. So there is a command in Matlab, this RGB to lab. So with that you can do that. Next, setting the parameters, how much value of m do you want. So if you remember the code, here there is this m sitting over here, which is used in calculating the distance, so that you can initialize over here. Then there is this n. So this n is the number of iterations, how many iterations, how many time you want to uh, loop this program. So that is number of iterations. And what is the value of k. So these three things are the parameters that you have to decide. Next, so let us just define them. So next, here capital N is the total number of. So one sec, let me just right. So here capital N is the total number of sorry. So total number of pixels over here. So that is I have taken the size. So the number of rows into number of columns of the image, that will give me the total number of pixels. Next, I'm just using these formulas that are over here. Okay, right. So now you have to calculate this gradient image so that you can shift the points that are on the edge. So for that we use this particular code over here. So you can see that this particular formula is used in the code. So I am extracting the this vector. Now this particular thing becomes a vector because it has R, G and B component. So this squeeze thing, this particular thing extracts that vector, the vector of that pixel, the pixels R value, G value and B value. So that is extracted over here. So gx is nothing but this bracket over here. So it says +1 y minus I minus 1. So this is the same thing that I've used here, +1 minus 1. So that is what I've used over here. And then gy is this other bracket, that is the y gradient. And then I've just squared all of them, squared and taken the norm. So this norm kind of a thing, that is just the normal L2 norm. So that I have taken over here. So like this I can find out the gradient of this particular image. So let us run the code till here and let us see how does the gradient look. So this takes a little time because this has so many calculations. So this takes a little time. Right. So here you can see that this particular loop has been executed. So now if suppose you want to see how does the image look, we can always show the image. So here you can see that G, this is a double image. So let us first convert it to uint 8 and then see. So I can say figure im show to show the image. First I'll convert it to uint 8 and then I will show G. Right, so you can see this is the gradient image. So here you can see the edges of this particular image are extracted. So this is our gradient. Right, so now that we have got the gradient of the image, now we have done these two steps. Now we have to create a grid with S spacing. So we have to create a grid like this. So this is the next task that we are going to do, that is initializing the centers of the key. This is the initialization. So for that, what I'm going to do is, we have s that we calculated over here. So I'm just so this s is in point. So since we are in discrete domain, we cannot have points as pixel. So first let us just take the top value of that and round it off. So I'm doing seal s, so that will round it off to 24. Next, what I'm doing is I'm creating a x grid. So over here I'm starting from s, that is this, I'm starting from here, and I'll go till the final pixel minus s. So I'll get this x grid. So that is in xcx. Similarly, I'll do it for y. So that will give me the y grid. Next, there is this p, which we'll understand why I've done that. And then there is this small loop. So this is just a vector. If you see cx, so cx is a 1 cross 36 vector. So it is just telling the locations of the x locations of these points, and cy is telling the y locations of these points. So now we have to use both of them together to make this grid, this whole big grid, because cx will just give me these points, cy will just give me these points. So now I want this whole grid. So to get the whole grid, I have used this particular loop over here, and I'm storing all the centers, that is I'm storing all these red values in a variable that is known as lock. So basically for location, so that's lock. And here I'm using this p, so that I can just concatenate it, the different these things into this lock. So that is why I'm using this p over here. So let us just continue and see. Right, so here the initialization has been done. So in lock, if you see, so over here in lock you can see the coordinates of all these red points. I have them over here, all the coordinates of the red points. So there are so many red points over here. So there are 864 red points, say. So the coordinates of the x and y coordinates of all the 864 points are there in this lock. Right, so now I just have to make a mean kind of a thing for this. So we need a vector, we need a mean vector, if you see it analogous to the k-means. So for every of this point, we should have the red value, the green value, the blue value, and its x and y. So we have the x and y in the lock, and now I'm just extracting the red component, the RGB, the green component, and the blue component. So this RGB content I have concatenated in the first position, the first three positions, and then x and y are in the next three. So so I have not shown that in this. Right, so this is for this particular thing, if you see over here. So we'll have a distance lab that you have to calculate. Right, so now we are in the lab space. So this is not RGB anymore, this is lab, because we are in the lab space. So that is one thing. So we need the lab for all the means that we have, this means that we have. So that is what I'm putting it over here. So this c vector that I have over here, let me execute this. Right, so this c value that I have over here is telling me the L value of, say this is the first pixel. So for this first, let me go over here. Right, so for this first mean, this first red point, this is the L value, this is the A value, and this is the B value. This is the x and y coordinate. So like this, for all these red points, I know the LAB value and the x and y coordinate over here. So that is what we have. And now we have to shift these coordinates, because if something is there on the edge, so we have to shift them. So I have explained in the video why I have to do that. So now we'll just shift the initial centers from there. So I am taking a window, so we can take a window of any size. So here I've taken a window of 7. So for a particular red point, it'll search in a window of 7 cross 7 box, and it'll move this initial points to wherever the minimum gradient is. So this small loop over here is for that. And so how am I doing this is as follows. So here I have a win variable that is 7 for now, and then I am taking the half of this, so that will be used over here. So this is the half of this. So let me show you the workspace as well, right? So a win is 7, and if you see n1, it is the floor of half basically, so it is 3. And next I'm making this low change. So if you see the low change variable over here, so this will tell me the coordinates where to shift. So this is from -3, -2, -1, 0, 1, 2, 3. So if there is a box over here, then in that box the center pixel is the 0th pixel for me, and if you go up, that will be first pixel. So that is 1 in y direction, 2 in y direction, like this. So that log change will give me that index as to where to go. So we'll see that how we get that. So now if you see this loop over here, so let me go into this loop. So this is for every center that I have. So for every red points over here, we have to move every red points to the value where the gradient is minimum. So that is this loop for. So now I'm making a H matrix. So this H matrix is extracting the 7 cross 7 window of that particular lock. So if this lock is the first pixel, then it will extract that first pixels this window, that is the 7 neighbors of this particular window. So let us see that. So if you see H, right, so this H is the 7 cross 7 pixels that are neighboring of this pixel, so that we can see over here. And about that law change that I was telling you. So here what I have done is this particular this is the center of this particular image. So this is 0 comma 0 as per my algorithm. So this becomes 0 comma 0, hence this load change will tell me that. So currently this particular pixel is over here. This is the mean for the first. So now I will have to take the minimum of this particular H matrix, and I will have to shift this red point from here to wherever the minimum is. So if suppose if this is the minimum, so you can see that this is 2.6 and this is 1.3. So what I've done is I've allotted every every number over here, every pixel over here as in a new coordinate. So the new coordinate will be given by this load change. So the fourth row is 0 for this new coordinate, and the others are as follows. So if I want to go over here, so that means this is 0 comma 0. So the same for y and x. So every 4 column 4 row is 0 comma 0, and I want to move over here. So from 0 comma 0 I want to go in x direction 1 2, and in y direction -1 -2. So in my y direction it will be -2 and x direction will be 1. So like this I am going to change this particular red point from one to other. So now that I have h, I am taking the minimum of h. So once when I take the minimum of h, it will give me a vector. Right, so what is that? A1 B1, right? So A1 you can see is a vector that is telling me the minimum values across the columns. So if you see H, so the minimum of these values is this number over here. the minimum of these values over here is this number over here. So 0 is this minimum over here. So like this. So A1 has all the numbers that are the minimum, and B1 is the actual location where that particular thing is minimum, the index. So here you can see the seventh column is the minimum, seventh row, sorry, the seventh row is the minimum. Hence B1 has this 7. So we are interested in B1, which particular index is 0. So for the columns, we get this from A1 and B1, and for the rows, we have to again take the minimum of A1, and we'll get the minimum number from there. So like this. And then if I just put them into this, wait, let me show you the code. So if I just put them into this thing over here, this small formula, so you can figure this out how I have used this formula. It is just the minimum of row and minimum column, and using this load change variable that I have. If you just see this carefully, you'll understand how this pixel is moving from one place to other. So that is what is happening over here. And then I'm taking the a and the lab value of that moved location and storing them into this c thing. So after that this loop is executed, you will see that now c has all the changed mean position. So now in c we have all the positions which has the minimum, which are not on the edge, which have the minimum edge location. So that is done. So now our main algorithm actually starts. Oops, sorry. Right. So now we have created this S grid as spacing. We have also moved the means which are on the edges. So now for every pixel in the image, search in a neighborhood of 2s. So that is if this is a particular pixel over here, so we have to just search in the neighborhood of 2s and assign that mean to that pixel. So we have to see the distance, whichever distance is minimum according to the distance formula, you assign that mean to that pixel. So this particular big loop is going to do that. And here I have shown iteration. So this variable iter will tell you which iteration is currently going on. And now we come to this thing. So here as I told you, this message is on that weight bar. So this will tell you what message you want on the weight bar. Now there is this x. So this x tells you how that green thing comes. So let me first bring that weight bar. Right. So here we have called that weight bar. So this f is called. That is, the weight bar has now called. Now whenever I use this particular weight bar x comma f, so you will see this particular thing over here. So it says segmenting, and there is no green over here. So why no green? Because x is 0. So I had initialized x as equal to 0. So when x is 0, there is no green. So this bar can be controlled by this x. When x is 0, there is no green. When x is, say, so let me make x is equal to half now. So now x is equal to half, and when I do this, so you will see that uh, half length has completed. So this is half green, half not green. So like this, by putting the values of x from 0 to 1, you can control how much green that you want. So what I'm going to do over here is, for me, this iteration is going to work as how much thing has been completed. So I have just updating x as iteration upon n. So n was the total number of iterations that I'm going to do, and iter is the current iteration that is going on. So this upon this will give me the progress as to how much iteration has gone, and you can see that very nicely in this thing. So like this you can implement this sort of a GUI kind of a thing to make your program more interesting, right? So now let us go into the program. So it is a very simple program for every pixel. So here I2 and J2 are scanning the pixels of the image. So every pixel over here, what we have to do is I am making a distance matrix. So this distance matrix will store the distance of the means that are nearby to the pixel. So that is there in this distance. And then k2, this k2 is for all the means that I have, the different means. So if they are if they are in a locality of 2s, so because we have to just search in a neighborhood of 2s, so if they are in this 2s, then only take the distance of that. So for this pixel there will be only these three means, I guess. So only then you take the distance and store that into this distance variable. Next, so for some pixels that are in the border, sometimes what happens is the distance variable is 0. So there is no mean that is close to that particular thing. So if it is empty, then don't do anything, or else if it is not empty, then just take the minimum distance. And we are interested in the index. We are not interested how much the minimum distance is, but we are interested in which mean is it. So I'm also saving the k2. So k2 is running for the means. So the different means that I have. So k2 one, the first mean, the second mean, third mean, like that. So k2 is pointing out the different means. So I'm also putting the k2 value in the distance so that we can get that k2 from by this command. So when I just take the row. So let us just run it once and I'll show you. So over here you can see the distance for the first pixel is over here. So there are two means that are close to it, and so there is only one mean, sorry. The rows of the distance tells how many means are close to it, and the column is 2. So the first is the distance, actual distance. K2 is it is close to which mean. So this first pixel is close to the first mean. Quite obvious. So this will tell you that. And here I am extracting the minimum. So over here it is just going to be the first thing, and I'm making an image O. So let me just okay. So this is running for the different distances over here in K2. So you can see so there was only this one mean that was in that 2s locality. So for them, so it is also running for others and checking this if condition, if that is that satisfying. So now we have this O matrix that I'm going to create. So this O is going to be our image, and for every pixel in O it is going to tell me that pixel is close to which mean. So the mean number is going to come over here. So let me just run this loop once so that I can show you. Right, so this will take a little time because there is so many things over here. Also, one more thing, you can make the image small if you want to run this fast. So because of that, I have kept I am resize over here. So if you make this image small, if you just make that image the half size, then the algorithm will run faster because then the number of pixels decreases. So that also you can do. Yes, so over here you can see a O is made. So now this O is telling, these pixels all belong to the first mean. Then when you go ahead, these are second, third, fourth, fifth, sixth, like this. So this is telling which each pixel belongs to which mean. So these are our super pixels that are formed over here in this O image. Right, so this O image is done. So now that we have assigned, so this is the assignment step. So once we have assigned each mean to each pixel, now we have to just take the sample mean of the pixels allotted to one mean and update the mean position like the k-means algorithm. So this particular loop is going to do that. It is going to just take how many pixels. So if you see for I is equal to 1 2, so this is going to scan every mean because it has to update every mean. So for every mean that we have, it is going to see if how many pixels are attached to that mean. So let me just step in. So for now I3 is 1, so I3 is 1. Now when I do this, so now I get all the row and the column index of all the pixels that were 1. So this find does that job. So if you see in the row and column, where is the row? Yeah, right. So here is the column. So I have 1351 pixels who had been allotted to mean 1, and these are the column index of those pixels. And similarly I have the row pixels over here, so 1351 pixels. And then I am just taking the mean of these indexes, and then I'm updating that location. So this is the update location, that is updating the means that is going on over here. So in this loop you will see that all the mean positions get updated. So now we have updated all the mean positions, and now we have to just iterate it. So just increase the number of iteration, and this x, update this x, show the weight bar. So this will tell me how much is the progress. So it has done this much progress till now, and again do the iteration. So like this iteration will go on, and it will tell you the image, it will show you the image. Also you can see what is the image at each level. So I'll show you that. So let us just quit debugging, and let us see how does at every level, how does the image look like. So here I am changing the so I let me resize this particular thing so that it works a little faster. Oops, sorry. Right. So let me run the code. So it'll asking me which file to open. So say this file. Oops, I did not remove the breakpoint. So you can see the weight bar has come over here. Initially it was 0, so it is showing me the 0th position. Oops. So now this is the image at the first iteration. So at the first iteration, this is what is segmented. So at the second iteration, this is what is segmented. So this I became a little problem. So this is the third iteration. So here the I has almost become okay. And this is the fourth iteration. Here you can see it is quite good segmentation. And this is the fifth iteration. So I have just used 5 iterations for now, because the algorithm, this was giving a quite a nice image at the fifth iteration. You can play with the different numbers of iteration that you want, and you can change those parameters over here. Where are the parameters? Right, so you can change the parameters over here, and use your image and do whatever. And here I am just taking the edges of this particular image and putting those edges on the image. So this small code over here is doing that. So that's all. So like this you can do the SLIC segmentation on any image that you want. Also about the fiery image, so let us see how did I make that fiery image. So that is with these commands. So previously Matlab used to have this thing to convert it to lab space, from RGB to lab. This is a new function that is implemented now. So what I did was, by mistakenly I used this old function, and then over here down, when I reconverted the image, when I'm reconverting the image, I use this new function. So because of that I got that fiery kind of an image. So let us see that output. So it is telling me, so let me select this image for now. Right, so here you can see this fiery kind of a thing. Oh, I have still kept the resize as this. So no problem, you can see you can still see the beauty of the image. So because of this resize, the image has become very small. So this image was already very small and it has become more smaller, but no problem. But you can see this beautiful effect that is due to one mistake that I made. So I just thought that this was something that I could share with all of you. So that's all for this video. Thank you so much for watching. Thank you so much.